Hey everyone, welcome to the third part of my Blender tutorial series, an introduction to geometry nodes. In this part, we'll focus on two main tasks. First, we'll create a basic version of Icing using a few powerful new nodes. After that, we'll create a gradient attribute and use it as a texture for our dough material. So by the end of this part, you'll have the most basic version of the donut completed, even with some really basic materials. Without further ado, let's jump into Blender and continue working on our geometry nodes system. Before we get to the main topic of this tutorial, let's organize our workspace a little bit. If you select a few nodes and press Ctrl J, a frame will appear. This is a great way to keep things organized. You can change the frame color under the N panel. You can also add a label by pressing F2 key with the selected frame or node. Adjust the font size under the N panel as well. Let's make a few frames like this to tidy things up. Our first task will be to separate the top part of our geometry to create a base mesh for our icing. There are a few ways to separate geometry in Blender, but the most straightforward method is to use Separate Geometry node. As the name suggests, this node separates geometry based on a selection field. We've already used a similar method with Scale Elements node, so this process will be pretty straightforward. We just need to think about which field we want to create. Let's switch to the side view. Our goal is to separate the top part of the donut mesh. What attribute could we use for that? The most obvious one that comes to my mind is the position, specifically the position on the z-axis. If we can get the position gradient, then we can use the greater than node to separate the desired part for icing. So, now we have a plan. Let's start by adding the Separate Geometry node and plugging it in. To get the position information, we need to add the Position node. As mentioned earlier, we want to focus on the position in the z-axis. To extract that information from the Position node, we need to add a Separate XYZ node. This one, similar to the Combine XYZ node, splits a vector into three numbers: X, Y, and Z axis. Let's plug it in and preview this attribute with the Ctrl-Shift shortcut. As you can see, we have a dark gradient in the z-axis direction. Great. Now we can use it to separate the geometry with the help of the greater than node. Let's add it. Now we can control the amount of separated mesh. If you switch between the outputs of the Split Geometry node, we can preview the top or the bottom part. Great. One thing that bothers me about this field is that it's not very scalable or flexible for the different sizes of donuts. If we change the size of the donut, the selected part will start at the same height, but the selected area will be larger relative to the shape of our big donut. To make this system more flexible, we need to adjust our field. A better approach would be to select not the part that is higher than 1 cm, for example, but maybe the top 20 or 30% of the donut. To do this, we first need to know the height of our donut. Then we can calculate the percentage. The calculation of the height is a great excuse to introduce the Attribute Statistic node. Let's add it and plug the z-axis into the attribute input. As you can see, this node also takes a geometry input but does not have a geometry output. The purpose of this node is solely for field calculations. And the important thing to note is that all outputs of the Attribute Statistic node produce a single value. Remember that the circular socket shape indicates that this output has only a single value, in this case a float number. This node calculates various statistics of attributes like mean, median, minimum or maximum values, and few more. The one that interests us is the range. By plugging in the geometry and the attribute into our attribute statistic node, this node will give us the range of z positions, which essentially represents the total height of our geometry. Now we can use this information to calculate the percentage. Let's add a math divide node and set it to 2. I am doing this because I want to consider only the top half of the donut. I don't want icing on the bottom. One thing that I didn't mention before about the math node is this clamp checkbox. When you hover over it, an explanation node will appear. This checkbox will clamp our output values from math node to the range of 0 to 1, which can be really useful sometimes. So, for example, if we have value of 2, the math node outputs 1, because 2 is greater than 1. So it's basically splitting all the upper values. To control the amount of separation, we need to add multiply node and plug it in between the greater than node and the divide node. Now we can select a specific percentage. Perfect. One last thing that can improve the intuitiveness of this field is to reverse its value. What I mean is that if the value gets bigger, the amount of icing should also get bigger. Currently, we have the opposite effect. We can fix that pretty easily. First, let's connect this value to the group input to control it in the modifier section. Now, to reverse this value, we will use a very useful node called the map range node. Let's add it here. The map range node is a math operation node that allows you to manipulate the range of attributes. For example, if you want to have a slider that ranges from 0 to 1, but we want larger values in our node system, like from 0 to 1000, this node will take our values and in that case multiply them by 1000. But we can create much more complex ranges. Here, we want to just invert our values. So for 0, the map range should return 1, and for 1, it should return 0. Let's set the toMin to 1 and the toMax to 0. Now, if we play with the value in the modifier tab, you can see that increasing the parameter gives us more icing. Perfect. That's exactly what we wanted. Now we are ready to proceed with the creation of the icing. Currently, we have just a simple bent plane-like geometry. Adding thickness to it would make it look much better. Currently, there is no Solidify node in the geometry node system. But we can recreate this useful modifier quite simple with just 4 nodes. The first step is to add an Extrude Mesh node. This node allows us to perform, as the name suggests, an extrusion operation. There are a few settings under it, so let's explore them. First, we have a drop-down list that allows us to switch between the extrusion on different parts of geometry, like faces, edges and vertices. Second, the mesh input is just the geometry that you want to perform extrusion on. The selection, just like before, allows us to select the part that you want to extrude. For example, just a few faces, not all of them. Offset is used mainly to specify the custom direction of the extrusion. By default, extrusion is performed in the normal direction, but maybe you want to extrude everything in the direction of the z-axis. We can specify it here with a simple vector. The offset scale is the most important setting that specifies the amount of extrusion. Lastly, the individual checkbox determines if you want to extrude every single element separately or together. So let's uncheck the individual option and set the offset scale to something a little bit smaller. If you look at our geometry from the bottom, we can notice that we don't have any geometry here. We need to fill it. For that, I will use our geometry before extrusion. To join 2 or more geometries together, we can use a really useful node named join geometry. It will do exactly this. So let's add it and plug in both the results of the extrusion and the state before extrusion. As you can see, this is the first node that allows us to plug multiple wires into a single socket. This socket, in the shape of rectangle with half circles at the top and bottom, allows plugging many wires into it. So, we recreated the Solidify modifier. Great. There are two technical issues now that we don't see at first glance. The first one is face normal orientation. If you don't know why the normal orientation of the face is important, let's talk about it in the simple example. In games, typically only one side of geometry is visible to the camera. This isn't a problem because we only see meshes from the outside, from the correct side. But if we accidentally get inside a rock or inaccessible building, we can see that these surfaces are often transparent. This is because in 3D modeling software we can specify which side of the geometry is correct, which one is the outside of the geometry. This is called normal face orientation. To preview it, check the face orientation option under the viewport overlays. Now you can see the bottom part of the geometry is red. In Blender, the blue color means the positive side, which you can refer to as outside normal, and to fix our problem we need to flip the normals in the bottom of the icing. Thankfully, this can be done easily with a single node named Flipped Faces. Let's plug it here before Join Geometry node. Now everything is blue. Great. First issue solved. One issue that I notice now are those edges that we can see on the edge of our donut. This is because when we separate our geometry we used point mode, and this can create these edges. We should use the face mode, because with face mode we are separating only faces. So there is no way we're gonna be left with those separated edges. The second technical issue we want to solve is overlapping vertices. When we joined the Extrude Mesh and the original one, we added this part of the geometry twice. Once with the extruded part and once with the original one. To merge these two separated mesh islands together, we can use the Merge by Distance node, which does exactly what the name suggests. Let's add it after the Join Geometry node. And that's it. We created our Solidify modifier. The Merge by Distance node is really useful and allows for few customizations. First, we can specify the distance. This essentially means that any points closer than this distance are going to be merged together. The drop-down allows us to specify if you want to merge separated mesh islands together. In our case, yes, we do. The selection socket doesn't need any special introduction at this point. The next part will be really simple. Remeshing. For that, we can just duplicate our node setup from before. Let's select these three nodes, Mesh to Volume, Volume to Mesh and Smooth group, and duplicate them with the Shift-D shortcut. Perfect. Our setup works great. We just created basic icing for our donut, which we'll use as a solid base for future adjustments. I think this is a good time to talk about performance. If we enable the timing option in the viewport overlays settings in the Geometry Nodes editor, we can see the time each node takes to execute. This is a great way to identify which parts of your node tree takes the longest to execute. As you can see, our total time is getting longer with each new node. If we continue at this rate, soon we will need to wait a few seconds for each change. That would make for a very unpleasant workflow. Fortunately, in the recent Blender release, a new node was added to save our day. The Bake node. let's add it and plug it in at the end. Now let's click Bake. Suddenly we can perform new operations really quickly. Why is that? Because what this node does is save the calculated geometry on disk. So Blender doesn't calculate that part of the node tree anymore when you change something after the bake node. This is really important because if you change something before it, like the radius of the donut, as you can see, nothing has changed. It will calculate new donut shape only if you click Bake again. If you would like to know more about this node, you can check out my other tutorial specifically about the bake node. So, we created the base icing and the donut shape. Let's join them together now with another join node. Great. To assign different materials to the geometry, we need to add a set material node. Let's add one for the icing and one for the dough, just before the join node. This way we can assign different materials. Let's create two materials, one for icing and one for dough. Now we can choose them in the set material node. Perfect. Let's go to the shader editor. Let's change icing material color to pink and slightly yellow / beige / brown for the dough. The last thing we can do to our geometry now is add smooth normals with a set shade smooth node. Great. The second thing I wanted to create in this part is the texture for our donut. In the Blender Guru tutorial, he used texture paint mode to add this color gradient to the donut. But since we are creating everything procedurally, we'll create the texture in geometry nodes too. Our goal now will be to create custom attribute that will look like that. Then we'll use that attribute in our material. So let's start. First, let's drag another wire and search for reroute node. This little tiny node allows us to keep order in our geometry nodes network. You can also create it by holding Shift and the right mouse button and dragging over the existing wire. Now, let's create a store name attribute node and name it texture painting. It will be a float attribute with point domain. To create this gradient, we'll again use our position. Let's duplicate the position and separate XYZ node from here. To get nodes out of the frame, you can use the shortcut Alt-P. Now, I want to create a perfect gradient that goes from 0 to 1. We can do this with the map range node. Now, we just need to know the minimum and maximum values of the position. We did something really similar before when we needed the range. As you can see, the attribute statistic node also provides us with minimum and maximum outputs. Let's add an attribute statistic node here and plug in the geometry input too. Now we can use the minimum and maximum outputs. Great. We can leave the toMin and toMax values as 0 and 1. Now, to create this type of gradient at the center, we can simply use a color ramp node. Let's add it. If you ever work on procedural materials in Blender, you probably know this node. It essentially works like a map range for colors, but with more intuitive interface. Let's plug our gradient into it. As you can see, if we start to play with these handles, we can change the contrast of our gradient. Let's add a third handle with this plus button. You can remove handles with the minus button. Now, let's place the white color in between, change the third color to black, and now we are ready to go. One thing we could improve in this gradient is to make it a little bit smoother. There's one node perfect for that, and we already use it. Can you guess which node I'm referring to? The blur attribute node. If we add this node here, we can make the transition much smoother. Let's increase the iteration number. Perfect. With this attribute, we are ready to go. Let's make a little bit of order here. I'll join everything from this attribute into a single frame. Let's jump back into the shader editor. To use geometry node's attributes inside the shader editor, we can add an attribute node, just like in geometry nodes. Now, let's copy the name of the attribute and paste it here. If we go to the material view now and preview it, we can see our gradient. Perfect. So, let's use a color ramp again, but this time inside the shader editor. Let's change some dough color to appropriate ones and plug this in as our color. Great. Congratulations! We created the first version of the donut entirely with geometry nodes. Good job! In the next part, we will focus on creating more interesting icing, so you can subscribe if you don't want to miss that. Thank you so much for watching. I hope you learned something new in this part of the donut series. If you want to support my channel, you can check out my Blender add-ons and asset packs, link in the description. The link for the final file that contains the complete donut and files from each tutorial part is also in the description. Thanks again for watching, see you again soon, and bye!